this lesson is the client-server architecture. So talking about the fundamentals of client-server architecture. A distributed system. A distributed system is a collection of independent computers that appear to the users of the system as a single system. So here information processing is distributed over the several computers. So look at the picture here. So this is a distributed system. That means the system is a collection of the independent computers that appears to the user of the system as a single system. That means this is computer is lot of the PCs is connected with each other and they work as a single system. That is we call the distributed systems. Network of workstation. This is one of the examples of distributed systems. In the manufacturing system, we can consider as the automated assembly line also one of the example of distributed system. Let's move to the next slide. What is the advantage of the using of distributed system? Or we can say, what are the advantages of distributed systems? So first one is the resource sharing. The software and hardware resources are shared. That means you can share the hardware and software resources. So this is the first one is the resource sharing. Second one, we can say that the openness. The software from different vendors are used. That means different kinds of software can be used in the distributed system. The third one is the concurrency. Processes are executing simultaneously. That means it can be executed one after another. Then the fourth one is scalability. Remains effective if resources added. If you add more resources, still the effectiveness is the same. Then next one is the fault tolerance. That is the ability to continue processing if a fault is occurred. That means it can continue if there is any fault, still it can continue the process. Then next one is the transparency. It hides the facts that the process and resources are physically distributed across multiple computers. So that means the resource and process can be done physically in the multiple computers. Next, what are the challenges of distributed system? The number one, we can say this is the complexity. Distributed systems are more complex than centralized system. That means there are a lot of things is there. That's why it is very complicated. Second issue is the security issue. More susceptible to external attack. More attack can come from the outside. Third one is manageability. More efforts required for system management because of lot of complex things is there. So it is very difficult to manage the system. So we need to put more efforts for the system management. And the next one is unpredictability. Unpredictable responses depend on the system organization and network load. Move to the next slide. Organization of distributed systems. So if you look at the organization of the distributed systems, a distributed system organized at middleware. So if you look at here, this is the middleware. So this is distributed based on the middleware. The middleware layer extends over the multiple machines. So the machines A, machine B, machine C, and the distributed applications after that, and the middleware that is software that manages and support the different component of a distributed system. It sits in the middle, so it sits in the middle between the distributed components of the system. So this is the distributed components, and the middleware is sit in the middle. Okay. Next, distributed system architectures. The first one is we call the client-server architectures. The distributed systems is which are loaded on by clients. That means distributed system servers which are called on by clients. Servers that provide the service are treated differently from the client that uses the services. And another concept we call here is distributed object architectures. In the distributed object architectures, no distinction between the client and server. Any object on the system may provide and use services from other objects. So that means in the client server, we have two things. One is the client, one is the server. But in terms of distributed object architectures, there is no distinction between the client and server. Object on the system actually provide and use services from each other. In the client-server architecture, the application is modeled as a set of services that are provided by servers and a set of clients that use these services. Okay? Clients know of servers, but servers need not to know the clients. The next one, clients and servers are logical process. That means the client and servers, they are do the processing logically. The mapping of processors to process is not necessarily one-to-one. That means the mapping of the server and the client. It may not be necessarily one-to-one. It may be one-to-many. So look at this picture, client-server interactions. If you look at this picture, you can see these are the server, S1, S2, S3, and S4. These are the servers. And the client is C1, C2, C3, C4, C5, C6, C7, C8, C9, C10, C11, and C12. So it shows client and server process rather than the processor. That means each of the server, they connected with the few clients. S1 is connected with the 4 clients, and then S2 connected 3, S4 connected with 2, S3 is connected with 3. It is normally for several client process to run on a single processor. So single processor will run different clients. Now look at the mapping of the client-server architecture. This is very, very important to understand. Mapping of the client and server to network computers. If you look at this picture, this is the network computers is here. Then in the top, C1 is the client. CC1 is the one computer, client computer. And CC4, look at the down. This is combined with C5, client C5, client C6, client C7. And look at the next one in the top, SC2. This is server, computer server. This is actually 2. Together we use as a logically is 1, S1 and S2. And next one is C2. Next one is C4 and C3. Down is CC6, C10, C11, and C12, the client. Together is 1, considered as 1 client. CC5 is C8 and C9. So if you look at this mapping architecture, so this is basically illustrates the situation where the 12 logical clients is C1 to C12. Okay, shown in the slide, this slide are running on 6 computers. Okay, 6, 1, 2, 3, 4, 5, 6. CC1, CC2, CC3, CC4, CC5, and CC6. Okay, clear? And then the 4 server processes are mapped onto 2 physical server computers. So you look at here, there are 4 servers, S1, S2. This is actually considered as SC2. Okay, this is the physical server. And another physical server, SC1, physical server. And this is actually mapped into the physical server is actually S3 and S4. All right. So now, so you understand the mapping of the clients and the server to network computers, how actually logically and physically it can be mapped. Okay, next move to the next slide. In the client-server architecture, the client-server systems have a clear separation between the presentation of information and the computation that process the informations. So there is a clear separation between the client and the server, how they process the informations. In the distributed client server, in that case, server systems are structured into several logical layers with clear interface between these layers. Just now I show you the server system are structured into several logical layers with clear interfaces between these layers. Okay, so there are 4 layers in the client server architecture. So the first one is we call the presentation layer, that is concerned with presenting information to user and managing all user interactions. So remember this one, this is concerned with processing information to user and managing all user interactions. Then second layer we call the data management layer. That is basically manages the data that is passed to and from the client. So the client requests the information, it goes to the server and server will process and send back to the client again. So data is managing through the data management layers. The next one is we call the application processing layer, that is concerned with implementing the logic of the application and so providing the required functionality to end users. So what are the requests coming from the user that will process through the application processing layer, and then after that is sent back to the client again. Okay, and the next layer is we call the database layer. So in this layer, it stores the data and provides transaction management services. That means whatever the data is coming, it is stores in the database layer. It will update the data and manage the services through the database layer. Okay, move to the next. Look at this picture, layer in the client server architecture. Just now we're talking about, first one is the presentation layer. There are 4 layers in the client server architecture: presentation layer, data management layer, application processing layer, database layer. All right. Okay, now move to the next slide. There are a few types of client server architecture layer. So number 1 is we call the 2-tier client server architecture. So what is actually 2-tier client server architecture? It is the simplest form of client server architecture. Okay, so it is the simplest form of client server architecture. The 2-tier architecture consists of client and server. That means this 2-tier consists of client and server. So there is a communication between client and server. The direct communication takes place between client and server. So what is the communication between the client and server? This is we call the direct communication. Whatever the client requests, let's go to the server, and server will give the feedback to the client again. The system is implemented as a single logical server. The system is implemented as a single logical server plus an indefinite number of clients that use the server. So the number of clients is indefinite. All right. For example, several clients update and save record in SQL Server directly. That means there are several clients, they update their informations directly to the server. We call the SQL Server, and they save the informations from the several clients. The 2-tier architecture again is categorized into 2 models. The first model we call thin client model. What is the first model? Thin client model. In this model, all the application processing, remember, in this model, all the application processing and data management is carried out on the server. Okay, so application processing and data management that is carried out on the server. Okay, the client is simply responsible for running the presentation software. That means client only responsible for running the presentation software. Okay, on the other hand, fat client model. So in this model, all the application processing is carried out on the client. Okay, data management and database function are implemented on the server. That means whatever the database update, that will done in the database management using the database functions in the server. Okay, that's all for today's lesson. So wish you all the best.